St. Joseph's College for Women Autonomous, Visakhapatnam, Department of Mathematics welcomes you for the online course on real analysis. Here, Modulo 1 is real numbers and real sequences. My name is Dr. V. Gauri Shankar Rao, MSc, MPhil, PhD, Department of Mathematics, Assistant Professor, St. Joseph's College for Women. Objectives: to develop a deep understanding of the algebraic and order properties of real numbers, including the completeness property and its significance in analysis. The second objective is to analyze sequences, their limits, and the necessary and sufficient conditions for their convergence. The objective 3 is to understand and apply the Cauchy criterion for convergence along with key theorems such as the Bolzano-Weierstrass theorem and Cauchy's theorems. The objective 4 is to explore the behavior of monotone sequences, properly divergent sequences and subsequences. The fifth objective is to enhance problem solving skills by applying real analysis techniques to theoretical and applied problems. After learning this Module 1, outcomes are: demonstrate a rigorous understanding of the real number system and its completeness property. Analyze and determine the convergence of sequences using various criteria including the Cauchy convergence principle. Apply the Bolzano-Weierstrass theorem to identify limit points and subsequences. Prove fundamental theorems in real analysis such as Cauchy's first and second theorems and Cicero's theorem. Develop logical reasoning and mathematical proof writing skills essential for advanced studies in analysis. The main objectives: problem solving skills. Here the Modulo 1, you learn Modulo 1, you have problem solving skills and how the sequence behavior, the Cauchy's and theorems, how you can apply the Cauchy's and theorems in convergence and divergence. The sequence analysis, you can identify the sequence, it is a convergence or divergence. At the same time, you can identify that algebraic properties. After learning this Modulo 1, understanding real numbers, how we can identify the real numbers, how we can it is a convergence or divergence. So achieve a rigorous understanding of the real number system and its completeness. The analyzing sequences, learn to analyze and determine the convergence of sequences using various criteria. Applying theorems, how we can apply the theorems. Apply the Bolzano-Weierstrass theorem to identify limit points and subsequences. At the same time, you can learn the proving theorems. Prove fundamental theorems in real analysis such as Cauchy's and Cicero's theorems. Developing proof skills. Develop logical reasoning and proof writing skills essential for advanced studies. These are the outcomes, the major outcomes of the Module 1. Let us see the basics on Module 1. Before going to this, you can see what is the sequence. So sequence means 1, 1, 2, 3, 4. This is called as a sequence. How we can write the sequence? Up to n plus 1 tends to infinite. So this is the sequence of the numbers 1, 2, 3, 4, so on up to infinite. So this sequence, it is denoted by Sn. This sequence is denoted by Sn. How we can write this sequence is Sn means, for example, before going to this, 1 to infinity is given now. Here you can write n equal to 1 to infinite. Here you can put n equal to 1 on Sn, you got that S1. S1 means what is that? First term value. So S2 means the second term value is the 2. You can denote this one as like Sn term. The next you can see what is the range of that. For example, minus 1 power of n is there. Minus 1 power of n. How we can write this? Minus 1 power of n is the range. Let us see this. Minus 1 power of n. Minus 1 power of n means how we can write this one? Minus 1 and 1 and minus 1 and 1. Here what is the range? The value is the minus 1 and 1. It is the combining value of the range. Here the two different values is given. So one is the minus 1, the second one is the 1. It is called as a range. For example, 1, 2, 3, 4, the so on is there. In this sequence, what is the range? How we can say the range? The combining all these terms is called as a range. And here the range is the 1, 2, 3, 4. So let us see this constant sequence. How we can say it is a constant sequence? In this Sn, you can sub that n value, any value, you have got only the same number. So for example, here you can put, I can put n equal to 1. I got that 2. At the same time, I can put that n equal to 2. I got that only 2. For example, I can put n equal to 3. So I got that only the 2. The 2 value is a repeated. The same number is the repeated. In that time, that sequence is called as a constant sequence. So let us discuss about subsequence. For example, that Sn, so it is from n equal to 1 to infinite. How we can write this one? S1 comma S2 comma S3 comma so on Sn and so on. In this sequence you can identify, for example, I need subset of odd, subsequence of odd. So how we can say it is an odd subsequence? So only you can consider odd numbers. So here what is the odd? S1 and S3 so on. These are the odd. So in that time this sequence they can denote as S2n minus 1. At the same time the subsequence even. How we can say it is that? You can say only that even sequences you have take. So for example they can denote as like S2n. So these are the subsequences. At the same time you can take that prime set also. So this type of subsequences, it is existed for the main sequence. The sequence it is denoted as Sn. The subsequence it is denoted as SNR. So NR means it is the particular. You can say it is the even sequence or odd sequence. It is a prime, also consecutive, whatever it is. So these are called as a subsequences. These all sequences comes from Sn only. So that's why this is called as subsequences. So here one more important point is, what is the lower bound? How we can identify that lower bound? For example, the set is 1, 2, 3 is there. The small value in this set, you can identify what is a small value. 1 is a small value. So this small value is called as lower bound. The next one is very important one is greatest lower bound or infimum. Greatest lower bound or infimum. How we can identify that greatest lower bound or infimum? For example, I can consider 1, 0, minus 1, minus 2, minus 3. Here greatest lower bound. Lower bound means what is that? The small value. So in these small values you can identify which one is the great value. That one is called as greatest lower bound or infimum. Here infimum means what is that? Infimum equal to 1. So greatest lower bound, you can identify that what is the small values. In that small values, which one is the big one? That value is called as a infimum or greatest lower bound. Next, let us see that upper bound. Upper bound means in that set you can identify which one is the big one. That value is called as a upper bound. So for example, you can consider series is 1, 2, 3 is there. In this series, upper value is the 3. So it is called as a upper bound. The next one is least upper bound or supremum. The least upper bound means how we can say that in this upper bound values, for example 1, 2, 3, 4 is there. Upper bound value is the 4. But in this series, what is the least upper bound value? So the 1 is the least upper bound value. So this least upper bound value, one more name is called as supremum. The least upper bound value is called as supremum. So infimum, supremum, it is very important in this module. The next very important one is bounded sequence. So any sequence, how we can say it is the bounded. The sequence is existed on the lower bound at the same time upper bound. Here you can observe that the K2 is the upper bound. K2 is the upper bound. So K1 is the lower bound. Here Sn is existed on the lower bound and upper bound. So this is called as Sn is bounded. For example, so -1 less than Sn less than 1. This is the lower bound and this is the upper bound. Sn is existed on lower bound at the same time upper bound. So then Sn is called as bounded sequence. So next one is, you can see the limit of a sequence. Limit of a sequence. How we can say it is a limit of a sequence? So limit n tends to infinite Sn equal to L. So once you can, n is replaced by infinite in this Sn sequence, you got that L. L means finite value. So you got finite value, in that time the limit sequence is existed. So here convergent means you can, how we can say that here n tends to infinite value, you can sub in Sn, you got that finite value, so once you got the final value, the given sequence is called as a convergence. You got that some finite value. So this finite value, so once you can replace n tends to infinite in Sn, you got the finite value, in that time the given sequence is called as convergent. So let us see this here, that important rule. For example, here they can use as notation is epsilon. So epsilon means it is a near to 0 value, but it is not a 0. So why you can consider that? For example, you can put 0 point, you can put that 10,000 zeros on after point value. So it is near to 0 value now. So here that one notation you can use the epsilon entire in this real analysis. So let us see this. Sn equal to L. Once you can replace n tends to infinite, you got that value. For example, Sn minus L equal to 0. But here real analysis, so Sn minus L you can denote it as epsilon. I said already it is not a 0, but you can consider as epsilon. In that time you can write modulus of Sn minus L less than epsilon. Modulus Sn minus L less than epsilon, they can denote as n greater than or equal to m. Actually the main one is Sn minus L equal to 0, but here you can't identify that exact value. In that time you can consider the nearest value, so that's why you can apply that epsilon. Here one more important point is, for example, the sequence up to 100 is there, S100 is there. So existed value is the S51. In that time, so S51 is existed and S52 also existed, and each and every value existed in that given series. So this is called as convergence. Here you can identify that n greater than or equal to m. Here n means what is that? The last value of the sequence. Here m means you can identify that what is the existed value. For example, m is the 50 is the existed. In that time each and every value, 50, 51 and 52 also it is a existed and the given series. Next important definition is monotonic sequence. So monotonic sequence means either the given sequence is increasing or decreasing. So in that type of sequence is called as monotonic sequence. For example, S1 and S2, S3 Sn, so on, Sn, Sn plus 1. So the sequence is there. In that time, how we can say it is the increasing sequence and so it means Sn greater than or equal to Sn plus 1, or so Sn plus 1 minus Sn less than or equal to 0. Here you got that negative values. Once you got the negative values, it is called as a decreasing sequence. Let us see this. Actually n plus 1 value is the bigger than to n value, but highest value minus lowest value got that negative values. In that time, that sequence is called as a decreasing sequence. For example, the increasing sequence means, so it is like reverse. You have got the positive values. You got the positive values. In that time, the sequence is called as a increasing sequence. Either decreasing sequence or increasing sequence is called as a monotonic sequence. So sometimes they can denote as like Sn greater than Sm for all n greater than m. This sequence is called as a increasing sequence. So otherwise Sn less than Sm for all n greater than m. So this sequence is called as a decreasing sequence. Here you can observe this. N is the given sequence and the lost value, but m means what is that? It is a convergent value. Convergence means it is a existed value. So that's why the most of them n greater than or equal to m. Comparing to m value, n is the big one. Why? Because of that one is the given sequence. So one more is, so the given sequence is convergent. Otherwise convergence means what is that? You got that finite value. So for example, the value is not a finite, so you got that undefined. In that time, the sequence is called as a divergent. So the sequence is convergent means after you can sub that n value, you got the finite value. It is called as a convergence. Otherwise, you got the divergent means you got that undefined value. So convergent and divergent. Let us see the mathematical definitions on this topic. So already I explained whatever it is before slides. So here you can see that. So mathematical like definitions. How we can write the definitions? You can say this. The first one is sequence. Already I said it is a sequence. S from n tends to a is called a sequence where n is a set of all natural numbers, a be any subset of n. So it is called as a sequence. You can take any natural numbers, you can write in one set. So it is sequence. Next one is real sequence. How we can write the real sequence? So S from n tends to r is called a sequence of real numbers or a sequence. Here you can take that only real numbers. So for example, you can take the note, it is denoted by Sn. You can take n equal to 1 to infinite. The range of a sequence, the set of all distinct terms of a sequence is called its range. Here Sn is set is 1 by n. Here how we can write, you can put n equal to 1, you got that 1, n equal to 2, 1 by 2, 1 by 3. So on. This is called as a range. For example, the set is minus 1 power of n is given. In that time, how we can say that range is 1 minus 1. So at the same time, the constant sequence. A sequence Sn is defined by Sn equal to c. For all n is called constant sequence. You can put any n value. You got that same number. So it is called as a constant sequence. The range of a constant sequence is a c. Why you can take that c? For example, I got the c is the 2. In that term, the 2 is repeated. You can put any value n, the 2 is repeated. So that's why the 2 is called as a range. The next one, you can see the bounded above sequence. So bounded above sequence, a sequence Sn is said to be bounded above. There exists L belongs to R such that Sn less than or equal to L for all n. Here minus 3, minus 2, minus 1, it is like bounded above sequence. So already I explained what is a bounded above sequence. The bounded below sequence means a sequence Sn is said to be bounded below. There exists L belongs to R So such that L less than or equal to Sn for all n. So bounded sequence means what is that? You can exist at lower bound at the same time upper bound. A sequence Sn is said to be bounded if it is bounded above as well as bounded below. So that is small l comma capital R belongs to L less than or equal to Sn less than or equal to capital L. L means small value, capital L is the big value. So the lower and upper value it is existed Sn sequence is called as a bounded sequence. So for example Sn equal to minus 1 power of n. So these are the definitions of bounded above sequence, bounded below sequence, bounded sequence. Let us see the theorems on this Modeule-1. The first one is a sequence Sn is bounded if there exists M belongs to Z plus, comma L belongs to R plus and A greater than 0 such that modulus Sn minus L less than A for all n greater than or equal to M. Let us see that a sequence Sn is the bounded. They said Sn is the bounded means what is that? We have that lower value at the same time upper value. So if and only if, for example, you can consider that bounded, you can prove as like convergence. So this is the convergence. M belongs to Z plus, L belongs to R plus. So M means what is that? Existed value. So Sn minus L modulus less than A. Once you can L means what is that? Once you can sub the limit n tends to infinity, you got that finite value. That finite value you can shift in left side, you got Sn minus L. So once modulus Sn minus L less than A. So you can take the bounded, you can prove this one. Otherwise you can take the Sn minus L less than A, you can prove as a bounded. Already you can simple this. The bounded means what is that? You have that lower value and upper value. So modulus means you got that upper value at the same time. What is that? Negative value at the same time positive value. So the simply you can observe this theorem statement. You got the bounded means it is the modulus plus and minus. For example, you can take the plus and minus, you got the bounded. Why? Because of the lower value is there at the same time upper value is there. Let us see the proof. Suppose that a sequence Sn is bounded. You can consider Sn is the bounded. Now we can prove what is that? There exists M belongs to Z plus, L belongs to R plus and A greater than 0. So it means positive value such that modulus Sn minus L less than A for all n greater than or equal to M. You can take the bounded condition, you can prove this one. So let us see this. Here Sn is the bounded. Bounded means what is that? You have that lower value and upper value. So there exists K1, K2 belongs to R. So K1, K2 is the it related to R such that, so already they said it is a bounded now. Sn is the lower value is the K1, Sn is the right value is the K2. K1 is the lower value and K2 is the upper value. So I can take the bounded condition. In this condition I can apply minus K1 plus K2 by 2 on each and every term. So I can take that K1 minus K1 plus K2 by 2. At the same time Sn you can minus them K1 plus K2 by 2. At the same time K2 minus K1 plus K2 by 2. Here K1 plus K2 by 2 is an extra term. You can apply the minus on this bounded condition. After cross multiplication 2 into K1 means what is that? 2K1. So like minus K1 minus into plus is the minus K2 by 2. At the same time Sn you can keep as it is. You can simplify this 2K2 minus K1 minus K2 by 2. So let us see this. So after simplification 2K1 minus K1 value is the K1. So minus K2 by 2. At the same time this value is the K2 minus K1 by 2. So after that here K1 minus K2 is there now. The right side value is the K2 minus K1. So the simple I can take the minus is a common. Minus K2 minus K1 by 2. So here you can see this. This is the minus value and this is the positive value. So K2 minus K1 by 2 I can consider some A. In that time can I write minus A less than Sn. L means what is that? K1 plus K2 by 2. It is a finite value. Sn minus L less than A. So minus A. Sn minus L is the variance from negative to positive. Can I write modulus Sn minus L less than A for all n greater than or equal to M. I can consider bounded. The final I can prove as modulus Sn minus L less than A for all n greater than or equal to M. It is the first case. Let us see this. Conversely, suppose that, so here you can take that second one. Conversely, suppose that there exists m belongs to z plus, L belongs to R plus, and A greater than 0 such that modulus Sn minus L less than A for all n greater than or equal to m. You can take this one, convergence related condition. Now we can prove that modulus Sn is bounded. So what is the bounded means? You have the lower value and upper value. So let us see this. Modulus Sn minus L less than A means what is that? The minus A less than Sn minus L less than A. So let us see this one. So minus A less than Sn minus L less than A. So after that I can apply the L on both sides. L minus A and Sn L plus Sn minus L plus L minus L is the cancel. You got that only Sn. So next L plus A. L minus A less than Sn less than L plus A. L minus A is the lower value. L plus A is the upper value. So lower value and upper value in between it is existed. It is called as bounded. So therefore Sn is bounded. Conversely it is the proved. So let us see that limit of a sequence. Before slide I explained what is the limit of a sequence. So let us see the definition. Let the Sn be a sequence and L belongs to R. So Sn is a sequence, so L belongs to R. The real number L is said to be limit of the sequence Sn if each given epsilon greater than 0, there exists m belongs to n such that modulus Sn minus L less than epsilon for all n greater than or equal to m. It is denoted by limit n tends to infinite Sn equal to L. Here n value can substitute that infinite in given Sn, you got that finite value. So in that time this sequence is existed. So that's why it is called as a limit of a sequence. Let us see that convergent of a sequence. So limit n tends to infinite Sn equal to L, then we say that the sequence Sn is convergence to L. So limit of a sequence and convergence of a sequence, it is a similar. Why? Because of once you can sub the value n tends to infinite, n value it is replaced by infinite, you got that finite value. Once you got the finite value, automatically it is existed. So once it is existed, it is called as a convergent sequence. For example, you got that undefined value. In that time it is a divergent. Either the given sequence is convergent or divergent. You got that L value, it is treated as like convergent sequence. Otherwise you got that undefined value, they can treat it as like divergent sequence. Note, a sequence which is not convergent is called divergent. Let us see that one more theorem on, if the Sn is a sequence of n, if the Sn is a sequence of non-negative numbers and limit n tends to infinite Sn equal to L, then prove that L greater than or equal to 0. Sn is the given Sn is a sequence. So what type of elements is there? Non-negative numbers. It is not a negative numbers. In that time, the limit n tends to infinite Sn equal to L, then prove that L greater than or equal to 0. You are already taken the series is the positive. So once the value also it is the positive. The simply you can see the proof. Given that Sn is a sequence of non-negative numbers and limit n tends to infinite Sn equal to L. You can take the non-negative sequence, you can prove limit n tends to infinite Sn equal to L. So now we can prove that L greater than or equal to 0. So once you can sub the value n tends to infinite, you got that finite value. That finite value, the compulsory it is a positive, either 0. So suppose that L less than 0. For example, you can take that L less than 0. Let epsilon equal to minus 1 by 2 greater than 0. So it is a negative value. So since already know the definition of this limit of a sequence, limit n tends to infinite Sn equal to L. So each epsilon greater than 0, there exists m belongs to n such that modulus Sn minus L less than epsilon for all n greater than or equal to m. So actually what is the condition of limit of convergence? Modulus Sn minus L less than epsilon. Can I write this one is minus epsilon less than Sn minus L less than epsilon. Both sides I can take that L minus epsilon, and here the negative L and positive L is a cancel. You got that L plus epsilon. So after that L plus 1 by 2 less than Sn less than L minus 1 by 2. So L plus so this one they can take as L by 2. So L plus L by 2 can I write, it is a cross multiplication 3L by 2 less than Sn less than, it is a 2L minus L. How they can write? L by 2. So 3L by 2 less than Sn less than L by 2 greater than 0. So let us see this. So Sn greater than 0. So which is a contradiction? You are taking the, actually they said sequence is a non-negative, but you are taking negative value. So which is the contradiction to Sn is a sequence of non-negative numbers. This is due to our supposition that L greater than L less than 0. So therefore L greater than or equal to 0. You are taken by negative values, but it is a supposition is a wrong. Our assumption is a wrong. So that's it is a only the non-negative integers. You got that positive value. So therefore L greater than or equal to 0. Let us see this one more theorem. If the sequence Sn converges to L and also to L dash, then prove that L equal to L dash. So actually convergence to L. Once you can sub that n tends to infinity, you got that L value and also L dash. The both are, you can say it is the same. Otherwise the theorem they will ask one more. Prove that the limit of a sequence if exist is unique. That exact value is called as a unique. Otherwise they will ask prove that every convergent sequence has a unique limit. Every convergent sequence has a unique limit. For example, the sequence 1, 2, 3, 4, 5 is given. In that time, you can sub that n equal to 4 value, that is called as a finite. Final answer, you got the finite. In that time, the 4 is called as a unique limit. So you can prove this type of theorem. Let us see the proof. Let us see the proof. Suppose that sequence Sn convergence to L and L dash. So Sn is the convergence to L. L means for example the 14. So L dash is the some 15. So here that Sn is existed of convergence L, at the same time convergence L dash. Now we prove that L equal to L dash. The both values should be equal. You can say like that. But suppose L not equal to L dash, I can against the rule. I can move on like against the rule. L not equal to L dash. Contradiction proof. L not equal to L dash. So L not equal to L dash means, can I write L minus L dash not equal to 0? Just simply can put that L dash on left side. You got that L minus L dash not equal to 0. So here I can write modulus L minus L dash greater than 0. Once you can apply the modulus, what is the value? It is a negative or positive. Actually it is the L minus L dash not equal to 0. So the same written as L modulus L minus L dash greater than 0. Let epsilon equal to modulus L minus L dash by 2 greater than 0. I can assume some value. So since Sn is convergence to L for every epsilon greater than 0, there exists M1 belongs to N such that Sn minus L less than epsilon for all n greater than or equal to M1. So let's convergence principle. The first, here I can take the two values. One is the L related, the second one is the L dash related. Again I can Sn converges to L dash. How we can write this one also? The same definition. For every epsilon greater than 0, there exists M2 belongs to N. So such that Sn minus modulus Sn minus L dash less than epsilon for all n greater than or equal to M2. Let small m equal to maximum M1 comma M2. So consider modulus L minus L dash. So here what is that? L minus L dash not equal to 0. How we can write this one? Modulus L minus L dash greater than or equal to 0. First I can consider modulus L minus L dash. So in this one I can add minus n plus n. Minus n plus Sn is called as 0. No? The same value got L minus L dash. So that's why you can apply minus n plus Sn. So modulus L minus Sn plus Sn minus L dash. So next you can see that. So this modulus I can separate the two. The first one is the modulus L minus Sn plus Sn minus L dash. So L minus Sn, it is called as a modulus. Modulus means you can write the either negative value, they can treat it as like positive. So that's I can write L minus Sn, it is treated as Sn minus L. So the second term is as it is. Sn minus L means by the convergence principle, modulus Sn minus L means what is that? Epsilon. So this value is called as epsilon. At the same time, this value is called as a epsilon. Epsilon plus epsilon is the 2 epsilon. So 2 into, already you are denoted now, epsilon means what is that? Modulus L minus L dash by 2. This is our assumptional value. The 2 days are cancelled, you got that modulus L minus L dash. So therefore, modulus L minus L dash less than modulus L minus L dash, which is a contradiction. You are taken by L not equal to L dash, but finally you got that modulus L minus L dash. So which is a contradiction. This is due to our supposition that L not equal to L dash. Therefore L equal to L dash. So your consideration both are not equal, but the final you got that L equal to L dash. So therefore your supposition is wrong. So note, if limit n tends to infinite, Sn equal to 0, then Sn is called as a null space, null sequence. Here you got that, for example, n replaced by infinite, you got that 0. In that time, that sequence is called as a null sequence. Let us see that subsequence. So already I said, what is a subsequence? It is like sub-member. For example, the one cricket team is there. You can pick up the some persons, wicket keeper and bowler and captain. So these are the sub in that team. So subsequence means if Sn is a sequence and Nr is a subsequence of positive integers such that n1 less than, n2 less than, n3 less than, so on, then the sequence Snr is called a subsequence of Sn. So example, 2n minus 1 and 2n are subsequences of n. So for example, this is a natural number sequence. In that time, 2n minus 1 is the odd sequence. The 2n is the even subsequence. So both are, it's come from sequence. So that's why these are true, it is called as a subsequences of Sn. So let us see the one more theorem. Prove that every convergent sequence bounded is the converse true. Justify your answer. Prove that every convergent sequence is a bounded. Convergence means what is it? Modulus Sn minus L less than epsilon. Modulus means you have the negative value and positive value. So once you have the negative value means it is a lower bound. So positive value means what is that? Upper bound. So automatically the convergent sequence is the bounded. Is the converse true? So converse means it is a reverse. For example, you can take the convergence, you can say it is the bounded. So justify your answer. So let us see that. Let the sequence Sn converges to L. Now we prove that sequence Sn is bounded. You can take that convergence property, you can prove Sn is the bounded. So what is the convergence? So since sequence Sn converges to L, limit n tends to infinite, Sn equal to L, for all epsilon greater than 0, there exists m belongs to n such that modulus Sn minus L less than epsilon for all n greater than or equal to m. So let us see this. Here n means what is that? Last value of the sequence. M means what is that? Existed value. So m belongs to n. So this m value you can sub in that and it is the existed value. So modulus Sn minus less than epsilon. So modulus means what is the negative value? Minus epsilon less than Sn minus L less than epsilon. Here you can apply that L. L minus epsilon. Here the negative L and positive L is the cancel. You got that Sn less than L plus epsilon. So L minus epsilon is the lower value. L plus epsilon is the upper value. So Sn is existed on lower and upper bound. So Sn is the bounded. The converse of this theorem is not true. So that is every bounded sequence is not convergence. It is very important, you can observe that. So convergence is a bounded. So convergence means you got that negative value and positive value. But the bounded sequence is not a convergent. Why? Because a bounded means you have the lower value and upper value. So convergence we got that only one value. So but bounded means you got that lower value and bounded value. You have the two values. Two values means it is not a convergent. So that is a very important. The convergent sequence is a bounded, but bounded sequence is not a convergent. So let us see the justify answer. Let Sn equal to minus 1 power of n clearly Sn is bounded but not convergent. Why? Because of minus 1 power of n. You have that minus 1 and 1. Minus 1 is the lower boundary, 1 is the upper boundary. So Sn is existed lower, at the same time upper, bounded but not convergent. Why? Because of you got the minus 1 value and 1 value, you have the two unique limits. So it is impossible. So that is a very important. Convergent sequence is a bounded, but bounded sequence is not a convergent. Why? Because of you have the two values. So that is the main reason. Let us see the one problem. Find m belongs to z plus such that modulus 2n by n plus 3 minus 2 less than 1 by 5 for all n greater than or equal to m. In this problem, you can identify in this sequence which value it is existed. When the sequence is existed, you can find the m value in this. Here actually this is the 2n by n plus 3 is the sequence Sn. So L, so less than 1 by 5. 1 by 5 is the epsilon, but you don't know what is the existed value. So existed means what is the limit value? Where is the limit value? You can identify that limit value is called as a m. So given sequence, what is that? Modulus 2n by n plus 3 minus 2 less than 1 by 5. So you can take the cross multiplication, 2n minus 2 into n 2n plus 2 into 3 is minus 6 by n plus 3 less than 1 by 5. So both negative and positive 2n values is a cancel. You got that minus 6 by n plus 3. These are modulus now, so that's why you can write the 6 by n plus 3. So 6 by n plus 3 less than 1 by 5. You can simplify this. You got 30 less than n plus 3. So 6 into 5 like 30. 1 into n plus 3, n plus 3. So after that, you can shift the values. 27 less than n. N greater than 27. So n greater than 27 means what is that? After 27, so that value is the existed. What is after 27 value is the 28. So in this sequence, m equal to 28. The limit value is the 28, and it means what is that? Existed value is the 28. Once you can sub in this sequence 28, you got that 1 by 5 less than 1 by 5. It is a simply. So any problem is given like this, you can identify that m value. You can simply remember that. So m value means what is that? Existed value. So in that sequence, which point is existed? That point is called as a m. In this particular problem, m value is the 28. So let us see that one more problem. So that sequence xn defined by, xn is the defined by 3n minus 1 by 4n plus 5 converges to 3 by 4. It is a little bit different. So here what the given one is 2n by n plus 3 is given before one sequence. Here what is the sequence is given by 3n minus 1 by 4n plus 3. So converges to 3 by 4. So that value is called as a 3 by 4. You can identify that what is the value of that. So xn means 3n minus 1 by 4n plus 5. Consider, so this is a value of xn equal to what the given one is 3n minus 1 by 4n plus 5. I can hear that what is the convergence value? Convergence means what is that? L value. L value what is that? 3 by 4. So modulus xn minus 3 by 4. So sequence is the 3n minus 1 by 4n plus 5. L value is the minus 3 by 4. So you can simplify this. You got minus 19 by 4 into 4n plus 5. So negative means you can remove the negative value. Why? Because of modulus is there. 19 by 4 into 4n plus 5 less than 1 by n less than epsilon if 1 by epsilon less than n. So therefore xn minus 3 by 4 less than epsilon for n greater than or equal to m. So greater than 1 by epsilon z plus. So therefore xn is sequence xn is converges to 3 by 4. So let us see this value. You got that some particular value now. So the particular value it is called as a less than epsilon. It is value, it is near to less than epsilon. Epsilon is a big one. 19 by 4 into 4n plus 5. You can put n equal to 1, whatever it is. You can divide this value. So compulsory it is less than epsilon. So less than epsilon means how we can write? Can I write like this? 1 by epsilon less than n. So automatically it is existed. So therefore xn is converges to 3 by 4. See this one more problem on sequences. If Sn equal to root over n plus 1 minus root n, then prove that limit Sn equal to 0. So Sn sequence is a root over n plus 1 minus root n. once you can put that limit n tends to infinite, you got that 0. 0 means what is that? You can say it is a null sequence. How we can say? Let us observe this. What is the sequence? Sn equal to root over n plus 1 minus root n. So 0 means L value now. So this L value you can shift the left side. Consider modulus Sn minus L. Modulus Sn minus L means what is that? Here the value is given 0. Modulus Sn minus 0. Sn value is the given sequence. So here root over n plus 1 minus root n is there. Just simply you can multiply divide with root n plus 1 plus root n, rationalized. So once numerator value a plus b into a minus b. So both roots are the cancel. You got n plus 1 minus n. So denominator is root over n plus 1 plus root n. So after that you can simplify this. N minus n is a cancel. You got 1 by root n plus 1 plus root n. So this is particular value. Can I write less than 1 by root n plus root n. So this value is compared to this 1 by root n plus root n is a big. So root n plus root n means can I write 1 by 2 root n? So root n less than epsilon. This value is less than epsilon. If n greater than 1 by 4 epsilon square, so therefore Sn minus 0 less than epsilon for all n greater than or equal to m greater than 1 by 4 epsilon square belongs to n. So here you what you got value, that value less than epsilon. Once it is a less than epsilon, so the condition will be true. So it is existed. So what you can take that Sn, the final limit Sn equal to 0. 0 also it is a finite value. So it is a convergence, but the sequence is called as a null sequence. So once you can remember that modulus Sn minus L equal to epsilon. So once you got that epsilon means what is that? It is not a 0, but it is near to 0. So it is some particular value is there. So it is a sequence. So let us see this one more problem. Show that limit nth root n equal to 1. So how we can write 1, you can shift the left side. So then Sn equal to nth root n minus 1. Nth root n can I write n power of 1 by n minus 1. So n power of 1 by n equal to this minus 1, you can shift the left side, you got 1 plus Sn. So both sides can apply that power of n. I got n power of 1 by n power of n, 1 plus Sn power of n. So 1 by n and the both are the cancel, you got n. So 1 plus Sn power of n. So this one you can write as like sequence 1 plus x power of n like sequence. So 1 plus n into s power Sn plus n into n minus 1 by 2 factorial Sn square. It is like nc0, nc1 like used on the formula. Then greater than or equal to n into n minus 1 by 2 Sn square for all n greater than or equal to 2. So this one can be written as n greater than or equal to n into minus n1 minus 1 by 2 Sn square for n greater than or equal to 2. It means 2 before values either equal to or 2 after values should be n. So this one can be written as 2n greater than or equal to n into n minus 1 Sn square. So then Sn square less than or equal to 2 by n minus 1. So I can cancel the square. I can apply the root on both sides. I got Sn less than or equal to root over 2 by n minus 1 for n greater than or equal to 2. So consider modulus Sn minus 0 equal to modulus Sn less than what I got root over 2 by n minus 1. So this value less than epsilon. If n greater than or equal to 2 by epsilon square plus 1. So already I said what is the condition? Modulus Sn minus L less than epsilon n greater than or equal to m. Here this is a m value. M value must and should it is a small value comparing to n. N greater than or equal to 2 by epsilon square plus 1. So therefore modulus Sn minus 0 less than epsilon for all n greater than or equal to m greater than 2 by epsilon square plus 1 belongs to n. So therefore limit Sn equal to 0, limit nth root n minus 1, that value is the 1. 1 is existed. Where it is existed? 2 by epsilon square plus 1. So in particular value it is existed. You got that finite value is the 1. So this is the problem. Thank you everyone.